Hello! I'd like to thank the organizers for inviting us to present on our recent work on Harappan Steatite beads and our presentation of a new methodology and preliminary results that provide fresh insights into the creation and circulation of value in the Indus civilization. Much of the work that we will be presenting on is based on Randall Law's earlier work estimating the geological provenience of steatite, and the artifacts that we'll be presenting on were kindly provided to us from recent excavations by Jeet Prasad, Pramod Shilvarkar, and Y.S. Rawat. We'll be presenting in a presentation in three parts. Part one is on the innovative methods that we have developed. Part two is on preliminary results, applying those methods to the materials that have been shared with us. And part three has to do with why anybody should care about this. So part one, the methods. Randy Law has spent more than 20 years now learning how to identify the geological source of steatite that was used by Indus people. Steatite is the stone, the rock that is comprised mostly of the mineral talc, which is very soft. Otherwise, it's also known as soapstone. It's so soft that it's a 1 on the Mohs hardness scale, can be scratched with a fingernail, and when it is fired, it gets much harder. Steatite has been long recognized as a very important material used by Indus peoples. This is going back to, this quote here on the slide goes back to 1934, when it was first recognized how important that steatite was in the Indus civilization. Randy's work at Harappa, going back almost 20 years now, has shown that steatite along with chert were the two most common types of stone that were used. And we'll remember that all stone at Harappa had to have been imported because of its location in the alluvial plains of the Indus River system. Here's just some pictures of objects that were crafted from steatite. The famous Indus seals are mostly made from steatite. Almost all of them are made from steatite. Tablets, these are unfinished beads that would eventually be turned into disc beads, tubular beads, or these are blanks for disc beads, but other forms of steatite bead are tubular and micro beads. And then this is what unfired raw steatite looks like. Randall was able to, back in the very early 2000s, collect raw steatite samples from all of these geological sources, and using a technique called instrumental neutron activation analysis was able to show that nearly all of the unfired steatite at Harappa and also other cities of the Indus civilization that he was able to from which he was able to analyze samples came from northern Pakistani sources, with only just a little bit coming from northern Rajasthan. He also learned that in the course of experimental studies that it's only this steatite from northern Pakistan that turns white when it's fired. All steatite turns hard when it's fired, but only, it seems, steatite from northern Pakistani geological sources turns white when it's fired. And this is great, but the methodology of instrumental neutron activation analysis, where Randy conducted the analysis at the University of Wisconsin-Madison, required up to 200 milligrams of sample, which is fine for unfired raw steatite samples, but not so much for beads. About 6 years ago at the annual conference on South Asia in Madison, Wisconsin, Jeet Prasad and Randy and I were talking about some new approach that he was taking with the director of the Instrumental Neutron Activation Analysis Lab at the University of Wisconsin, and they came up with a way to analyze samples as small as 5 milligrams, not 200 milligrams. And this actually might allow us to estimate the source, the geological source of the steatite from which individual beads were crafted. This is huge. And over the course of 2018 to 2020, we put together a new database of 155 heated geological samples so that they would be directly comparable to beads, which were most likely fired. 155 heated geological samples from 12 different geological sources across 5 regions. This is just showing our work. This is the creation of the new fired steatite database. These are the raw samples. These are them going into the oven and the cookies that came out. Our initial results on the basis of this new database of fired steatite samples was applied to a series of whitened steatite beads that were shared with us, and the ones that I'm going to be presenting on today are in this picture that came from archaeological sites, Indus archaeological sites in the Indian state of Gujarat. There they are in the context of the total pilot study, which we are continue to work through. These are the archaeological sites from which they derive: Bagasara and Harappa, excavated by, and Jaita and Loteshwar, all excavated by Maharaja Sayajirao University, and Kotada Bhadli, excavated by Deccan College in partnership with the State Department of Archaeology, Gujarat. A first step of this analysis is X-ray diffraction to, one, confirm that the beads are actually made out of steatite, and two, estimate the temperature to which they had been fired in order to turn them white. And one of the first observations that we made was that 3 of the 4 beads that were shared with us from Kotada Bhadli were not actually steatite at all, but nontronite, which is a local claystone mineral, which to the naked eye is almost indistinguishable from steatite. We were fooled, and certainly individual people in antiquity would have likely also been fooled. It was the first recognition of artificial steatite. We hesitate to say fake, but artificial. But the 4th bead was, like the others, comprised of steatite. And here's just a closer look at the X-ray diffraction curves, should we be interested. But note how similar they appear. Nontronite, 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 steatite. This is the first 2 functions in a canonical discriminant function analysis of the composition of the fired steatite samples from all the different geological sources. These are the geological sources, and as we suspected based on Randy's earlier work, all of the beads generally fell into the cluster of fired steatite samples from northern Pakistan. There's one possible exception, which is that 4th bead from Kotada Bhadli that may have come from Rajasthan. It's important to understand that this canonical discriminant analysis provides an estimate based upon the samples that we begin with. This requires some further work. But almost all the others, from Bagasara, Loteshwar, Shikarpur, and Jaita, appear to have derived from geological sources in northern Pakistan and thus circulated all the way down to Gujarat from the extreme north to the extreme south of the Indus Civilization, with maybe one of the beads from Kotada Bhadli coming from a Rajasthani source. Now, who cares? Well, we care because we put some time and some effort and some resources into this. But I think everybody who cares about the creation and the economic and social organization of the Indus civilization should care about where the beads came from, because these beads are perhaps the most distinctive and ubiquitous artifact of the integration era, as Massimo Vidali wrote in 2000. And their production was both the source of the raw material as well as the production of beads from the raw material seems to have been really tightly restricted. And so at a workshop for the beads, I showed these on an earlier slide, that Mark Knoyer excavated in 2000, he wrote that the beads may have been strung on specific lengths of cord and used as a form of standardized exchange in addition to being worn as ornaments. And he went on in 2010 to say that a string of steatite microbeads clearly represents a considerable amount of time and effort, and it's not unlikely that standard lengths of strung microbeads may have been used in trade and exchange. And so I wanted to make sure to share those quotes as part of my presentation, because these ideas are not completely original, but rather we are following up to evaluate this hypothesis. The hypothesis being that the source material of the steatite beads was as restricted as we might have thought based on Law's earlier work. And in general, our pilot results of this new innovative methodology do support that hypothesis, that the white and stone steatite beads share physical properties with money, that they're durable, they're portable, they're relatively uniform. There's a couple different shapes and sizes, but they're relatively uniform, and they were definitely limited in supply. So these are physical properties that are really quite similar to coinage, which is the type of currency that this general definition used by economists was derived from. We don't know if they were acceptable as a form of payment for all different sources of debts and as a storage of value. We don't exactly know if they could have been divisible, if you could pull beads off of a thread, off of a string, and use them on their own, or if they only circulated as ornaments. And we do not know the extent to which they were interchangeable with one another. But the physical characteristics of these beads now do seem to be very similar to general definitions of currency. But as anthropologists think about currencies and money, we realize that money isn't a thing at all. It's a way of comparing things, as David Graeber wrote in his widely read 2011 book called Debt, that summarizes a lot of this economic anthropology. And one of the observations that anthropologists have made is that there's general purpose money. This is what circulates as dollars or rupees today, and we can use it for all different sorts of purposes. And that contrasts with something that previous generations have unfortunately called primitive money. You can hear it in the tone of my voice and my use of scare quotes that I don't like primitive here, but it's a word that was used during the colonial era and continues to be the search term that you need to use if you want to learn about this stuff. And these, I'd prefer to call them social currencies, circulate in the context of social relationships, to cement relationships between families in the context of marriages, between communities, to cement relationships, and anything more specific than that becomes sketchy because they were used for different purposes in different times and different places. And these are wampum beads. This is an example from North America during the time of European colonization. They were originally crafted by native peoples from marine shells that had white and purple portions, so the beads are either white or purple, and they initially circulated as social currencies within and between native communities to cement relationships and treaties, but quickly came to be adopted by European colonists as a general purpose money, and experienced inflation and counterfeiting and all the same sorts of processes that other general purpose monies are subject to. And so that demonstrates that the same kind of object can function as a general purpose currency as also a social currency in different contexts. And so it's really important for us Indus archaeologists who have control and an understanding of the context and association in which objects are found. And this is in addition to the analysis of their physical characteristics that we're describing today. So general purpose money might be represented by different shapes and sizes of beads all being stored together, as maybe coins are in a piggy bank, and social currencies might have been kept together as ornaments and found together. Sometimes we have this information, and a lot of times we don't from older site reports. And I just want to show two examples from Gujarat of sites from where our beads come that illustrate why it's important and how this can become rather complex. So here we are in Gujarat, zooming in. Here are two sites, Shikarpur and Bagasara, from which literally thousands of whitened stone beads have been documented, and we've now studied a small handful of them. These are the archaeological sites. They're very small. Bagasara is less than 1 hectare, and Shikarpur is about 2.5 hectares of walled area. They're surrounded by these massive walls. There were lots of manufacturing and trading activities that took place within them. And note the Steatite beads outnumber any other class of artifact that could have been worn as an ornament. And note that this number here from Bagasara does not include the unfinished beads the unfinished bangles from the workshop. So Steatite beads definitely are dominating in both of these sites. They occur in about half of the layers that were excavated at both sites, and occur, there's a handful of them at each. The median number that occur in the layers that have them. At Jekta, on the other hand, was a rural site. These are hut floors. And at that site, there was one pot with a whole bunch of beads that were all uniform in size, found together as if it were an ornament. So at these two different sites in Gujarat that were occupied contemporaneously with one another, at one site they're distributed all throughout the site, and there's a wide variety of shapes and sizes. And at the other site, Jekta, they're very, very uniform and seem to have been kept together. So were they used for different purposes at these two sites? This is something that will become more clear with more detailed contextual analysis alongside more instrumental analyses of the geological source of the material. So to conclude, we can now reconstruct the circulation of these highly valued currency-like objects, and we need to analyze more beads, more shapes, and more sizes from more sites, and we need to do this in tandem with reconstruction of the context and association in which they were found. And to do that, we need more collaborators. We are looking for partners to participate in a long-term program to study the Steatite economy of the Indus Civilization and the construction and circulation of value. And if you have been involved with an archaeological site and would like to work with us, we would like to hear from you. Thank you very much.